Okay, so we're looking at this question here. We have to solve C74 or 74. This is basically just ask. This is a combination. It's a counting technique. Okay, you've got combinations and you've got permutations. Both of these are counting techniques. It's just that with permutations, order matters. With combinations, order do not doesn't matter. And you see combinations being used in some formulae in probability, like in the binomial distribution. All right, there is a combination in that formula in the binomial distribution. So this is the formula for a combination: C equals n factorial over n minus r factorial r factorial. N represents the total number, okay? And n is usually the one top here. Okay, this is n. Even here, the number which is on top is n. Then your r is the number at the bottom. So colleagues, we can solve now. I've showed you the n and the r, so I hope you're not expecting me to start solving. Because while we're doing this, some of you were present during that time. So I hope you need to also participate. Okay, don't just look and say, "Oh, I remember that one, but forgotten how to solve it." No. So yes, colleagues, we can solve. We know our n, the top number, which is the total number of things. Then r is the bottom number. So for example, you can have 7 books. Then you want to find 4 ways you can put them in combinations. So we can solve. Then you tell me your answer. If you are lost, you can let me know also. Yes. For those who are joining, this is the question we are solving here. This one for combinations. So the reason why it's quiet is I'm waiting for answers. Okay. So what you can also do is you try to solve by yourself. Then I said, if you are lost, you let me know. If you remember how to do this, then you just solve and you give me the answer. So I'll be waiting for the answer. When you find the answer, you just let me know. You say, okay, sir, I found this answer. And you explain how you get it so that people are not thinking it's magic or you just guessed. Yes, has anyone found an answer? Has anyone found an answer? Mr. Twambo, have you found an answer? Yes? Correct. Wonderful. We move on to the next question. Mr. Twambo, please explain to everyone how you got 35. 7 minus 4. Factorial. Factorial. Yes. Team, are we all okay with this? Mm-hmm. Uh, the top number is n because it remains. It's like it's the total number of things. Okay. So whatever number is on top will always be n. Okay. Then the bottom number is like a subset of the top number. Okay. You have 7 books, then you want to put them in combinations of 4 books, 4 books, 4 books. You want to know how many combinations of 4 books can you put. Okay. So the top number n is the total, then bottom number is just like a small group from the total, which is at the bottom. Yes. Is that okay, sir? Now here we have a permutation. Okay, as I said, what separates the two is permutations follow a certain order. Combinations, there are no orders. Okay, so permutation, um, uh-huh, that's a formula for a permutation. So let us try this permutation. So what are these used for? Combinations, you saw this one in binomial distribution. Okay. Mm-hmm. Let me see if that's correct first. Huh? 236. Mm, 3. Mr. Anchimonia. What is 8 factorial? 40,320 divided by 5 factorial. When you divide the two, for the combination. Okay. Mr. Chimunya, use this formula here. Okay. Which which make is it? Yes, which brand? So basically, it's what's saying you've got eight things and you want to arrange them in groups of three, basically. But now we don't know what things this can be. Okay. And in these groups, order is going to matter. Okay. The difference between the two is permutations, orders matters, combinations, order doesn't matter. Okay. We can get the combination here. I believe we all remember the formula. Do I need to write it down here or we remembered it? Because remember, when you attempt a binomial distribution on your formula sheet, you see it written as this. Okay, the part for the combination. So it's you who needs to remember the formula for a combination. Okay, because the good thing about your exams is for statistics and probability, the formula will be there for you. Okay. I'll share with you the sheet that they usually give you for the formulae and the tables. Yes. So let's get the combination here. Out of eight things, we want to arrange them in orders in groups of three. Now here in these groups of three, order doesn't matter. Okay. On which part? Where I was saying that out of eight things, you want to arrange them in groups of threes, and order won't matter. Is that what you're talking about, sir? Both P and C. It's just that when you're arranging using permutations, order doesn't matter. When you're arranging using combinations, order matters. But in this case, they haven't told us what these things are. So they're just giving you P83 and C83. They haven't told you it can be people, eight people, you want to put them in groups of three. It can be letters, it can be numbers, various things. 56. Yes. Are we all getting 56? Have we all got 56? Okay. So, Mr. Chimonya, let me just read through the topic again. I'll give you a practical example when I read through this topic again, okay, sir? So that you can visualize. Because this topic, the way I hated this topic, the questions are confusing. Mm. Yes, but has everyone got 50, 56? Hello, can you get me? My data was done, so I don't. Are you able to get me? Okay, Mr. Chimunya can get me. Okay. So I was asking, have we all got 56? Are we all okay with this so that we move on to the next part? Okay, please, where are you having a problem? Oh, Mr. Dennis. Oh, Mr. Dennis, how are you? I'm fine. Yes. Have you seen the formula we've been using? No. Do you have any problems with that first one, the first tabulation? Oh, so you are more concerned about the second one. Okay, the formula we used was this one. You just add an R factorial outside, okay, sir? You just add an R factorial on the other side. Are you able to solve this? Do not worry, this is being recorded. Okay. But if you are able to solve the first one, here is just putting the R outside there. Okay. Just put Yeah, it's just putting the R outside there. Then you'll be any other questions? Oh, colleagues, wait, sorry. This formula won't be provided in the exam. They won't be provided. I'm just going through let me just show you the document you'll be given in the exam where these formulae are. And I hope everyone has this document, okay, by Professor Abuino. Yes. Have you seen for binomial distribution? Here you must remember that combination formula. Have you seen the way it's presented here? So you must remember the combination formula for binomial distribution. So I don't think here, I can't see the combination and permutation formula. So I don't think you'll be given. Uh-huh. This document. Okay, I'll share this one. I'll share it after the class. Yeah, because this is the one you'll be using. And once you can interpret all these letters, yeah, you'll be okay with it. Okay, I will share with you, sir. Okay. Once the class is done, I will share with you. Hmm. I wouldn't just share to Mr. Twambo alone. That would be very unfair of me. It would be very, very unfair of me. Okay. Yes, colleagues. So that's how you deal with permutations and combinations. Okay. Yes. So now we go to the next part, which deals with logarithms. The logarithm is just like the opposite of an index. One practical use of logarithms is it helps you smooth graphs. Okay, if you've got a graph like this and it's hard to interpret it, if you apply logarithms, this crooked graph is going to become like this straight line which you can interpret. That's one of its practical uses. Okay, yes. So let me just beam these laws of logarithms because you must remember the laws of logarithms as you are doing this question. Can someone get a screenshot? Or before you get the screenshot, let me transfer it to the board so that as I'm solving, we are seeing the laws of logarithms being applied. Okay, so it says given that log BP equals X and log BQ equals Y, express in terms of X and Y, log BP, okay, or log B PQ squared log B P over Q cubed log B square root BP squared over Q. So I'm just going to show an example of part A. Then part B, I'll expect you to solve because everything that I'm going to be doing is just going to be applying here to this. Okay, so I want to see who are the real mathematicians. So colleagues, we're starting with this one, log B PQ squared. Okay, we have to express it in terms of X and Y. Now, colleagues, first thing you should notice is we've got the power 2 here. Okay, we got q to the power 2, and we've also got pq squared. So first thing that you should notice is that these two, since they are attached like this here, you should know that whenever variables are attached like this and you're dealing with such equation, just know you have to apply the product rule, which is this rule here. So in this case, we're doing the product rule like this. Have you seen? Here we have log b, you have your p q squared here. So if we apply the power rule, it's going to become log b p plus log b q squared. Now, before I go to the next step, any questions, colleagues? B is this, which one here? This one here, this is B here, and this is B here. Log B P plus log B Q squared. Okay, this is what you call the base of the logarithm. Okay, this B which you're seeing, this small letter B, that's the base of your logarithm. So, sir, it's log BP plus log B Q squared. Can I continue? Any other questions? We've just applied the product rule. That's the first thing we've done. We've applied the product rule. Okay. The thing about it is this: we want to put our logarithmic expressions where we have a log BP so that we can substitute it with an x, and want to have a log BQ so that we can substitute it with y. That's the whole concept here. Okay. All of these expressions, this one, and this one, you want to simplify it down to a log BP and to a log BQ. That's what's happening here. So that you can eventually substitute X and Y. Yes. Any other questions? Mm-hmm. Yeah, yeah, yes. And I see a lot of people and saying, this question, will I even waste my time on it? Colleagues, this question is 10 marks. Hmm? Would you want to give up 10 marks like that? Mr. Nchimunyo, would you want to give up 10 marks like that? So long as even if you end here, at least when they're marking you, if you end here, they'll give you 1 mark here. 1 mark. I'll share that. Oh, I've seen. No, sir. The good thing about this is this: with your confusion, it brings understanding. Did you know that? With your confusion, it brings understanding. With your confusion brings understanding. Yes. Let's just not specialize in confusion, okay, colleagues? Do not. Inshallah, it's Professor Humphrey. Okay. Yes. So, colleagues, this question is just combining algebra and logarithms. Okay. They like to do this a lot in mathematics, combining these things, logs, algebra, and whatever. Okay. In real life, you won't be using these logarithms. Oh, but for compound interest, if you remember that formula for compound interest, if you want to find the time, since t is a power, whenever you've got an equation, okay, where, like, let me just illustrate here. I'm not trying to confuse you more, okay, just trying to illustrate something here. Okay, so this compound interest formula, okay, it's a very practical formula because you can find out, okay, if I invest this amount of money in here in a certain place, how much will I have, and whatever. Yes. So whenever you want to find this t, whenever you don't know the value of this t, you have to apply logarithms so that this t now comes down with the expression. Okay, so that's one way also use logarithms. If you want to find the value of a power, you have to apply a logarithm so that that power comes down into the equation. Okay, so that you can find the value of that power. Okay, but that's just a side note. That's just one of the applications of logarithms when you want to find the value of a power in a equation. So, ha- can I proceed with this question? Because I'm not done with it. We have just done step one. Okay, step two now. Because remember, log BQ hasn't got a power, so I want to get rid of this power. Okay, so have you seen the power rule of logarithms here? Log bm to the power k, this power just comes in front. Okay, this power k has just moved in front here. Okay, so here this 2 is going to move in front here. Oh, now my workings are looking messy. Let me put it here. Yeah, we'll start with it. I want the handwriting to be dark so it's visible to everybody. So this power 2 is going to come in front of the logarithms, okay, colleagues? So it's going to read 2 log b q. So we have log b p plus the 2 will come in front. 2 log b q. Okay. First we had log bp plus log bq squared. Now that's this 2, this power 2 comes in front. We've applied this power rule for logarithms. Okay. So the power comes this side. So it's on 2 log bq. Then now we can substitute. Log bp, they said it's x, so we substitute it with x. Log bq is y, so you have a 2 log bq is y. So the equation forms 2x plus 2y. Any questions? Can I give you one to try, which is just similar to this to see if you've understood? Can I give you one? Okay, so here you have log b p cubed q squared. Same here, log bp equals x, log bq equals y. So expressed in terms of x and y, log b p cubed q squared. Let me just beam the power rule so that you can see it. No, the other one is cubed, q squared. Yes, 3x plus 2y. Because if it's 3x plus 2x, then you need to add both of them so that it becomes now it is 5x. So, yes, 3x plus 2y. Yes, another question? Hmm. No, they'll give you in the question. They'll give you in the question. As you can see, they've just told you log BP equals x, log BQ equals y. Mhm. Now I've just made it up. Yes, yes. What is your answer first? What answer have you found? What have you found first again? Maybe it's correct. You say, is it 3x plus 2y? Yes. Uh-huh. Yes. So your log BP just substitute it with x. Log BQ, you just substitute it to y. We are moving, yes. Okay, anyone else? Any questions as we move further? Because remember, this is just surface level. Okay, this is surface level. Okay. Okay, we go to the next one. Log B P cubed. Uh-huh. Can I erase this part? Can I erase which thing? That's James. Oh, wonderful. What about Madam Betha? Or permutations and combinations? Okay, once yes, it will be uploaded. Mhm. Okay, how is it going, Madam Betha? Are we winning or? Okay, okay, Madam Sylvia, I know it's okay. Madam Mary, are we okay with this? I hope we're okay with this. So, colleagues, since people are saying, ah, we're okay with this, it's sinking in. Okay, here's the next one here. Log B, P over Q cubed. Now, you look at the laws of logarithms and you see which law should I apply next. Rule number two, yes, the quotient rule. Okay, whenever you are dividing, there's a logarithm and there are two things being divided. You break it down like this. So, Mr. Twambo, what does it break down into? Oh, wait, let others also solve. Because if you're answering like that, some people will say, ah, let me not even solve. After all, Mr. Twambo, give me the answer. And I'll sit next to him in the exam. Because Mr. Twambo, people are coming to sit next to you. Mm. Mm-hmm. 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 Yes, yes. But you've skipped a step. Just put the step before that so that everyone is following. Yeah. Yeah. Okay. Mm-hmm. Yes, you can think of it like that. This over sign, since it's a car, it's a line. You can think, okay, so it's minus, so I'm subtracting. Yes. So, colleagues, are we okay with the answer x minus 3y? Okay, I want to make sure everyone is clear with them. Wonderful. Madam Mary, you hear a voice in microeconomics. You hear it in micro and accounts. Yes, log BP, it breaks down to this. Log BP minus log BQ cubed. Then remember, when you have the power, you apply the power rule. So this 3 comes in front here. So it becomes log BP minus 3 log BQ. Then log BP is X, log BQ is Y. So it's 3Y here. X minus 3Y. Yes. Now we got. Oh, any questions before we go to part C? Because part C is going to be interesting. Okay, can I erase this? Has everyone written this down? Okay. We can now go to part C. We've got a square root BP squared over Q. So here, colleagues, here's the hint. You just need to try to separate these. So let me hear from you. How can we separate so that at least we can have two terms? Because as you can see in these laws of logarithms, you have two terms. Okay, here you have got three terms, B, P, and Q. But you want to put it in a way that, okay, no, we should have two terms. How can we do that, colleagues? Anyone to give it a try? Because before we apply any law of logarithms, we have to have two different terms. Yes. Anyone to try what? How can we split this? Oh, she's revising. Okay. Okay. Before that, actually here no law of indices will apply. Okay, okay. I've heard that when you get the reciprocal, yeah, you can put it like that. Let's say with the reciprocal. Okay, let me help out here. Colleagues, you can make one a fraction, B over Q multiplied by P squared. Okay? Or if you want, you can say B P BP squared multiplied by 1 over Q. Okay. Or you can put it as this. Let's see. P squared over Q times B. But as you are doing this, you have to see which one will be the most consumer friendly way here. And the most consumer friendly way is going to be this one. Okay, you are going to see why in a matter of time. So colleagues, are we okay with this first step where we first split them? Mm, okay. You can arrange it like there are many ways of arranging this thing, madam. Okay, there are many ways of arranging it because you're asking basically why this p square doesn't got a denominator. This one here, right? No, not necessarily, unless when it was a plus sign that you would have q would have been on both sides, plus or a minus sign. But if it's like this, because remember, if you multiply p squared times b, you get p squared. Have you seen? So this splitting holds true. So when they are multiplying terms, okay, the denominator is not for everything because if I put a q here, madam, it means when we multiply this, it means this has to be a q squared here. Okay. So there has to be one denominator because if there are two and you multiply back to the original equation, you will see like in this case, if I put a q under the p squared, if we multiply it back to the original equation, we end up having a q squared in the denominator, which is not the case. So the denominator will be for only one term. Okay, madam? It will just be only for one term. I don't know if that has answered. If it hasn't, you can still rephrase. But if it was addition, so remember this, colleagues, if it was addition, if it was b plus p squared over q, then now you have to, both of them will share this q, b over q plus p squared over q. So that when you add back this fraction, you get this. Okay, colleagues, so now next thing, since we can separate the square roots like this, we got to put a log bp here like this log b. So this can simplify to log b square root of b over q times square root of p squared. Okay, colleagues, you have seen what I've done. I've split the square roots, okay, according to law of thirds. Okay, here we're applying the law of thirds. A, square root of A times square root of B equals square root of A times B. So this here is the law we've applied here. So that you can easily get the square root of P squared. Okay, square root of P squared is P. Any questions before we move further? Colleagues, how do we get rid of this root in terms of making it now an index? How do we convert this root into a power? One, this square root here, we want to get rid of it. So we have to apply a law of indices. So when we apply that law of indices, what will that square root become when it's converted into a power? Yes. Yes. Hmm. We got the square root of P squared. So it's not magic. So should I go deeper? So maybe I should I dig deeper? Let me no, let me dig so that you get the full understanding. You can also apply this same law of indices here. So it would be P squared, the power half here. Okay, this root becomes half. 2 times half, that is 1. So you remain with P to the power 1, which is just P. Much better. Or this dot, it's times, yes. In mathematics, a dot can represent times. If you want, you can put it at the x there. If you want, you can put them together like that. So these are university notations. These are university notations. Indeed, you are the representative. Okay, so colleagues, here, which law of logarithms will we apply first? We've simplified, we've got log b over p, the power half, times p. So which law of logarithms? Yes, law number 2. It's better we start with the product, law number 1. Then law number 2 will come into play. But I believe if you start with law number 2, means but before you apply law number 2, first you have to get rid of this half. You have to bring the half in front, then you apply law. Yeah. Okay, so Before we bring the half, we can do it like this. Okay, we can do it like this. Since here we've got b over p to the power half times p, so we can apply the product rule so that it becomes log b over p to the power half plus log b p. Is that okay, Mr. Twambo? Okay, is that okay, Madam Geraldine? Is that okay, Madam Betha? Okay. You can apply the other rules so that when I was solving this one, I applied this one. Okay. Yes. So then here you can apply now that power rule where you bring this half in front. So it's going to be half log b over p plus log. So this log bp here we can substitute, but we'll substitute later on. Okay. This one here can be easily substituted. Then now we can apply the quotient rule. Because I think b over p here, you can apply the quotient rule. So it becomes half log b minus log. This is a q here. Log, yeah, it's a q here. Log b q plus log b p. Okay, we're just doing the steps, same slowly by slowly. Okay, yes. Then we can do the substitutions. Now, colleagues, whenever you have a situation like this where you have the base is the same now, like here, log b, here is the law that you apply. Okay, when the base is same as the number, for example, if this was log 5, you get a 1. Okay, if it's log 6, you also get a 1. So whenever the base and whatever number you have here are the same, you get a 1. So this is going to become half, open brackets, log b, that is 1, log bq, that is y, and log bp, that is x. So you can leave your answer like this. If you want, you can distribute the half times 1, half times y, half y plus x. Any questions? Or should I should give a similar one to this so that no one should lie at, sir, we've understood. Can I give a similar question? Okay. Then those who are trying, those who have still got questions on this one, you can still ask. Okay. So you have log b. Log square root b p squared over q cubed. Then those who are still confused, you can still ask on these workings that I did. And those who are okay can try this one. Yes. Have you found an answer? Mm-hmm. Uh-huh. Mm-hmm. Yes. Wonderful, Mr. Trumbo. Wonderful, sir. Wonderful. Mm. Mm-hmm. Wait. Let's see. You're saying 1 plus 2. Mhm. Means over 2. Basically, are you multiplying this with the whole of this with the numerator of the fraction? You need to, no, sir, no, sir, don't do that. Uh huh. The way I've switched the x and y. Let's see. Maybe let's see how did you break down your. Did you break it down like this? B over q cubed p squared. Did you break it down like this? Okay. Oh, okay. Send a screenshot. Carry people. Some people are stuck, so they're waiting for me to start solving. First, send your screenshots, sir, so that they can be forced to solve. Mhm. Okay. Mm-hmm. Mm-hmm. Doesn't apply. I think maybe you is yours like this: bp squared, then the square root of 1/q cubed. Is yours like this? This side here. Since you're asking about that power, did you isolate the q cubed by itself? It's in the square root. This square root applies to this b and this q cubed. Like here for p squared. No, because as I said here, you have to break this into. two terms. So one term is going to be a fraction. And then this q cubed, since it's here at the bottom there, unless if it was like this p squared by itself and you are getting the cube root, you would have easily got it. But q cubed, you can't easily get the square root of it. That's why you just need to convert this root into a fractional index. Okay, so if it was b to the power 2, you would have done like this, like this, huh? Yeah, b squared, you can get the square root because you can do it like this. Square root of b squared, also here, square root of q cubed. The square root of b is b over square root of q cubed. Then now you apply the, what is the quotient rule. Then yeah, then this square root for q cubed, you just convert it into now a fraction or index. Then you would have. Actually, that's the question I should have even given you. It looks like, but it would have been interesting. Yeah. Oh, oh, okay. So yes, whenever you're doing with letters, don't do that approach, sir. Okay, please next time don't use that approach. Yes, colleagues, are we all finding half minus half open brackets 1 minus 3y plus x? Okay, Mr. Twambo, my co-presenter, Mr. Twambo, you'll be explaining, I'll be writing, okay? Uh-huh. Okay, they've Mr. Who was this? Mr. Who was it? Was Mr. Not Mr. Foster, Mr. Casono, yes. Mr. Casono said, let's use what's user friendly. You convert the square root into a fractional index, right? Mhm. Oh, first wait. You should have said it like this, Mr. Tuambo. Then you should have said it like this. You first do the what's this product rule. Log b over q cubed to the power half plus log b p, right? Yeah, like this. Mm-hmm. Okay, it's called the power rule. Okay, the power rule. Oh, so yeah. Okay, okay. Okay. This the second one is the quotient rule. It's rule number what? Or rule number three. Well, rule number three, right? Where the power? Yeah. Okay, let me just write them down so that you remember. So, number one, it's the product rule. Okay, you're multiplying everything m times n. So, when you're multiplying, the rule is just based on what is happening in the bracket. So, product rule. The number two is quotient rule. Okay, even in calculus, we're going to learn this. Number three, power rule. And number four, colleagues, what did we call rule number four? The one rule. Eh? Can we call it the one rule? Rule number four, I don't know the name of it. Number five, I think same base something rule. I'll get the names for five, six, and the other ones. Okay. Oh, let me go back to the workings. So, after we apply the power rule, let's continue, Mr. Tondo. Mm, yes, like that. Quotient rule, yes. Just a minus, just a minus. Mm-hmm. Mm, yes. Colleagues, are we following any questions? Feel free to ask questions, okay? Mhm. Mhm. Yes. Mm. No, 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 no. No, 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 no. Yeah, yeah, yes. Well, half time. If you want to leave it here, you can expand half times one half times 3y. This is 3 over 2y plus x. Wonderful, wonderful. Colleagues, any questions, queries? Mm, he's enjoying at the farm. Oh, yes, you've been vocal actually. Yes, you have been vocal. Yes. Mm. He's, they confused you there. Hey. Oh, it's, tomorrow is accounts. Tomorrow is accounts. Tomorrow is accounts. Oh, I'll update you. I got the timetable from you, Mr. Tombo, so I'll update it, okay, so that we know which classes are what on which day. Okay. Yeah. Yes. Colleagues, any other questions? Now, my battery, have you seen my battery is low, and I'm helping a pastor with his research. Okay, this is a pastor. I'm helping a pastor with his research. Colleagues, do you want to know what his research is about? Okay, let's finish this. Colleagues, just have the module. Just have the module. Yes. But for Professor Apwin, him, the course outline is just his quizzes or whatever assignment. Yes. In the module, you're free to go through it. Okay. You're free to go through it. Goodness is not a very long module. It's about 100 pages. But majority of what will come is from his assignments and questions. Yes. Yes, Mr. Chimonyi, you're saying I just finished one more. The other one will get you more confused. The one which is coming next. Okay. Huh? You're asking for what? Okay, okay. Yeah, yeah. Ah, yeah, 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 yeah. Hey, you give people heart attacks. You give you give you give people heart attacks here. Okay, you are saying that I finish one more question, sir. Okay, good night, good night, colleagues. Homework. Oh yes. Mm. Who was refusing homework? At homework, yeah, child. Madam, you need to do homework. Okay, let's see. Eee, wonderful. 96. My A plus. My A. Mm. Okay, colleagues, have a wonderful. Oh, here's a screenshot. Get a screenshot of this. This is homework. Rules of logarithms, just you. Oh, also you get a screenshot also. Have you got the screenshot? Okay. Colleagues, have a wonderful evening. We'll meet tomorrow in accounts. Tomorrow is accounts, yeah. Accounts. Has anyone attempted to make the ledgers? I felt lazy to make those ledgers. Has anyone attempted? Oh, okay, 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 okay.